Hello, thanks for attending my presentation. What I wish my regression run manager's vendor knew. I'm Brian Craw from Infineon Technologies. Together with my colleagues David Crutchfield and Jason Lambirth, we wrote this paper outlining our experiences in using two of the major EDA vendors' regression management tools. We're part of Infineon's central organization that provides digital verification methodology and tool support across the company. In our time at Cypress, before the Infineon acquisition, and now as a part of Infineon, we've had the opportunity to roll out both Siemens Questa Verification Run Manager and Cadence's vManager, now called Vericio Manager, both of these regression management tools. We not only enabled them for verification teams, but integrated them into an internally developed tool that we call Verification Management System, or VMS for short. This tool provides a standard look and feel and interface for all users of the vendor's tools. The issues, solutions, and lessons learned outlined in this paper are a direct result of our experience with setting up, deploying, supporting, and maintaining these tools in our own development environment as a part of VMS. I'll provide more details on VMS in a moment. This paper is not intended as an exhaustive comparison between these tools, but rather a documenting of our experience and lessons learned with the major features of each. To start, I'll go into a little background on how we have standardized the use of these tools. Then I'll go into some detail regarding the lessons learned and our efforts to make use of the regression managers themselves. Our requirements on these tools is that they provide us enough flexibility to standardize the look and feel of a verification engineer's regression environment, which allows for a user to move from team to team, project to project, or business line to business line, and still be able to know how to launch a regression with as little effort as possible. This is where the verification management system comes into play. What is VMS? VMS is an internally developed tool intended to provide a standard environment for functional verification work to take place. It was developed over 10 years ago by David Crutchfield at Cypress Semiconductor before the acquisition by Infineon. Please read the paper presented by David and Tom back at DVCon in 2014 for all the gory details. It's pretty good. It provides, this tool provides design and test bench compilation, simulation, regression, management, formal application execution, as well as provides for some standard report generation and messaging. The power of this tool is in the standardization of the regression environment setup and the output it provides back to the user. VMS is not a replacement for a regression manager, but is a complement to one. It basically is a wrapper around these tools. It further abstracts and standardizes the user's environment and its setup. VMS generates the given regression manager's control and setup files, and then executes these tools. This abstraction aids in removing the complexity of learning a vendor's custom tool setup, like having to manually create and edit a VSIF file or an RMDB file. It generates or provides these files for you. It also allows the look and feel of the environment setup to stay nearly the same while changing the underlying tools, which gives us a level of vendor agnosticism. Of course, simulator options will be different, but where and how those options are provided largely remains the same. The experience we've obtained in developing VMS to use these tools and internally then supporting them over the years is the bulk of the source of the information provided in this paper. Our first topic is regarding how do I control and customize what this regression manager is going to do. For the most part, this is accomplished via custom control files that hierarchically describe to the run manager the tasks it should perform. For Siemens EDA, Questa VRM tool, this is accomplished via the RMDB file, or Run Manager Database file. For Cadence vManager, this is accomplished via the VSIF file. To start, we'll discuss the RMDB file. This file hierarchically defines what are called runnables, which describe the flow of the regression. Runnables can execute any type of script. They're fully customizable. These runnables can be executed conditionally, and we use this feature of VRM to execute all of our steps. So we use the RMDB launches and executes our compilation steps, our optimization steps, simulation steps, obviously. We also use it to precompile C code before tests are launched. It generates reports, and we also have support to launch and run the Questa formal application, sometimes in conjunction with the regression itself. This file format can be is pretty powerful in that it provides not only a description of what to do, but also provides some programmability within itself. So there are things called these user-defined tickle procs. For what this allows us to do is provide a little bit more dynamic flow inside of our RMDB. So rather than having a fixed rigid file, what we can do is within the parameterization of each runnable, call these tickle procs, and then based on control files that, in our case, VMS generates, it can understand what it should do. Should this runnable be executed or not? How many sims to execute? What are the DRM settings? All these things can be extracted from external files. This is a pretty powerful feature. The other side effect is we also are able to override some of the default VRM procedures with these tickle procs. So VRM provides hooks into the regression flow, and these are called, these methods are called at key points in your regression, such as whenever an action or a task or a runnable is started or completed. There are some other ones having to do with analyze pass fail. So did this task pass or did it fail? Is it okay to merge the coverage results? Things like that. We overload a lot of those methods. One of the main reasons we do that is so that we can do our own regression status tracking. We want to provide some more user-friendly messaging out to the terminal. So as these scripts are executed, what we can do is detect which action started or completed. Did a simulation start? Did it finish? Oh, it finished. What's its state? Oh, it failed. Here's a path to a log file. We can provide all this information by overloading these methods. This also gives us one other feature that we make a lot of use of, is kind of monitoring the state of the regression. Regression managers already do some of this for you, but we go a little bit beyond that, and some of the common issues we found, mostly in LSF management or our grid or network issues or licensing issues, we can detect some of these common issues ahead of time or while they're happening, and dynamically adjust our regression for them. So remove a host from the list if we are detecting a lot of, everything is failing on that host with certain types of failures, not necessarily simulation failures, but like system type failures. This provided us a lot of power, and rather than waiting for the regression to just spew out thousands of failed simulation messages that the user then that's not very useful for them, we can get out ahead of that and minimize that, getting more value out over a nightly regression and giving some users some feedback as to what happened. It wasn't their test bench, it was host ABC on the grid had a network file system access issue. So a couple challenges that we encountered while using VRun and the RMDB in particular is the same properties that make it very flexible and powerful allowed us to overload it. Also led us to having a single RMDB that was very programmable and dynamic, but it was very large and grew and grew and did not really did not scale well from a support standpoint. So what we would like to do in the future is be maybe more generating an RMDB instead of using one monolithic one that has all the control embedded in it. And then from there, we can use the runnable features, and we can call external scripts to do a lot of that processing for us. The processing can then be done in more user-friendly programming languages like Python or Ruby or Perl even, and which makes support a little easier. TCL is not the most friendly programming language in syntax, and especially then when you wrap it inside of XML, which is what happens a lot inside the RMDB file, it can become fairly painful to debug the file itself. Especially syntax highlighters and code editors just aren't big fans of mixing the markup language with the scripting language and supporting both. One of the other issues we ran into was really more of a VRun in particular issue, which was performance with very large regressions of small, fast tests. So what would happen is, due to the single-threaded nature of the tool, we can either launch jobs or we can service jobs. So what happens, a bunch of jobs get launched, those jobs start quickly finishing, and the tool then is interrupted to service the finishing jobs. And then while doing that, it's prevented from launching new jobs. What this led to, and it's a very specific case where we have lots of short, usually C tests that are running, is we were starving our grid. Like we would drain all the jobs running, and then VRun would get freed up to go launch a bunch of jobs. and then we would see us starve the grid again, and then a bunch of jobs would get launched again. One enhancement that we'd like to see is some control over this. Can we give some sort of weighting between launching and servicing so that we can maybe prevent these bottlenecks? And if that was something we could dial in, then a user knowing that they're running a large regression with small simulations could kind of dial that in a little differently than someone running lots of longer simulations. Next up, we're going to talk about the vManager control file, which is the vSIF file. This is a little bit more straightforward format file, nested text format, kind of JSON-ish like format, a little simpler than the RMDB. It doesn't have the embedded scripting like we see in the RMDB file. This is, on the one hand, makes it a little easier to manage. On the other hand, we lose some flexibility with it. As I previously stated, we can go overboard with this flexibility, but having a little bit of control embedded in the file is nice if needed. Unlike our vRun implementation with VMS, which relied on a single monolithic RMDB to rule them all with all the embedded controls, when we had the opportunity to update VMS for vManager, we decided to be more strict, and we generate an RMDB for every regression. A VSIF for every regression. So we take the user inputs in the VMS format, the standard kind of agnostic format, and we will generate that VSIF for the user. They never need to open it or look at it if they don't need to. Of course, they can if they want, and then launch vManager on their own. But this is also another powerful way of using the tool, and probably more along the lines of what it was intended if you are going to have some automation around it. A couple of challenges that we encountered while using the vSIF file. The biggest one is that the vSIF syntax assumes the script being executed at the leaf node, i.e. the test node is launching a simulation. So at first glance, this may seem reasonable. It is a regression manager for running simulations for the most part. However, during our attempts to drive other types of jobs, such as compilation scripts for either our Verilog, system Verilog test benches, or C code, run report generation, whatever, we found this to be a bit of a limiting factor. We could put scripts to execute these jobs at the leaf node, but upon the regression completion, the test summary results were a little skewed. Jobs that were not tests were counted as such. You can always try to take this into account, but if you're looking at the vManager GUI itself, it can be a little misleading to tell you that 13 tests ran in pass when you only ran a regression that had 7, because it's counting things like pre and post scripts and pre and post group scripts or whatever it may be. That being said, even if we could force the coverage for the test to be 0 so that it wouldn't affect overall test count, which leads to confusion when reading reports, we attempted to create groups in the vSIF that consisted only of pre-group scripts with no tests, and then the pre-group scripts should run our compilation jobs. And we're really looking just to get the hierarchy, this tree set up. But vManager ignores structures in the vSIF that don't have any leaf nodes. They don't actually have a test associated with them, so the scripts weren't launched. One enhancement we'd like to see would be some sort of flag or a tag inside the leaf node to say this is not a test, right? Go ahead and execute this thing, but do not track it in the coverage database. Don't try to merge results of it. Don't show it as a test, so to speak. Nodes not tagged as tests would still be executed, but no built-in assumptions as to what they should be doing. This would be left to the user. A similar issue stems from the fact that in our environment, we have, and I would assume most environments, we have multiple compiles per test group. So we don't want to perform a single compilation, one monolithic compilation of the whole design or test bench, but we may want to launch many compilations to compile various portions of the design and test bench independently. This provides us more control later when only specific portions of the design or test bench need recompiled. This is helpful in large SoC projects where we don't want to wait for an entire chip to recompile because we touched one aspect of it. We can lump these compiled jobs together into a single pre-group script, but the effect is they're all launched serially, not in parallel. And in a lot of cases, there's no dependency on these. If we know that in our verification management system, we have a feature in place that allows us to know this. What is what can be compiled separately, what should, what shouldn't. So we make quite heavy use of this. We also need to wait for all the compiles to finish before elaboration occurs. So therefore, to get around this, we wrote our own job manager script for just the compile jobs, and it is in and of itself a pre-group script. And so what it does is it launches and it manages launching the cloud jobs in parallel or serially, depending on their, what the prerequisites are. And then when those are done, it then proceeds to do the elaboration as needed. So again, we've been able to work around this, but it would be nice if there was some native support in the tool to help us make use of the VSIF structure and this hierarchy and this tree without forcing us into the context of running simulations. Next topic is batch versus GUI mode. It's maybe a hot topic amongst the audience. Some people love batch, some people love the ability to have the GUI open and see everything in front of them. However, in our VMS implementation, we mostly make use of the batch mode or the regression managers. VMS automatically generates all the control for the regression managers. It launches the regression manager, provides real-time feedback through our messaging hooks, generates post-regression reports, and so for most regressions, this is best done in batch mode because we're wanting you to just be able to go to a command prompt and type a command, not launch a GUI, interact with it, pick what test you want to launch, things like that. This is all possible, and there are certainly use cases for that when it comes to debugging and active development. But when you're running regressions, or short or small or large, sometimes you just want to be able to type your command and hit go. If a user manually is writing a VSIF or an RMDB, then loading the GUI and manually selecting the jobs that they want to run every time makes sense. Like you may not want to rewrite your VSIF or RMDB every time. You just have one big one for maybe different types of regressions. And you would just load it up and you would select, I just want to run these three, I want to run this one, I want to run all of them. However, VMS is managing that for you on the front end, so it's not really necessary. The other advantage of batch mode is it gives us more control over the real-time reporting. And quite frankly, myself, and maybe I'm old school, I don't know, but I like just a terminal with text coming over it telling me what's going on. It's usually a little more straightforward and simple than having a GUI up that I gotta keep moving out of the way or manage. But what we can do, we use these custom hooks, and we'll get to it in a second what we do with vManager, but the custom reporting that VMS provides, this is just streamlined and coming out to the terminal, and we don't have any of the other noise that may come with a GUI. The other side effect is the computational cost of actually launching a GUI and running it. Maybe not a big deal, but sometimes it could be, just depends on where you're running at. And finally, for if we wanted to enable VMS to work with continuous integration tools, then we would want to be able to run in batch mode. So VMS is inherently more, VRM, our experience, VRM is inherently more batch-based. It does have a GUI, we've used it, but quite frankly, I would say less than 0.1% of the time do I ever open the VRM GUI. vManager leans more towards GUI interaction, and again, we'll get into some more details here in a second on that. But it just, some of it's user preference, and some of it is practical as to how your environment is set up. So some of these lessons that we've learned between the two regression managers in the batch versus GUI discussion is, excuse me, vManager does provide an API that you can use from the batch from a terminal to extract real-time metrics from the running regression. They call this the V API. We attempted to integrate this into VMS, and quite frankly, there's licensing costs, there's performance issues with doing it since we're accessing things over a web interface, so through a web server, a REST API basically, making it a little slow, so we moved away from that. And basically are now pretty much using vManager in batch mode. We still support you launching vManager in GUI mode. You can do everything yourself at that point. We'll go ahead and build the VSIF for you, but for daily regression running, the default would be batch mode. Conversely, VRM stores regression data in the UCDB file, so it's continually merging the results into this global UCDB file. We then use VMS to periodically pull this file to gather information, metrics. And since this UCDB file is just sitting there on disk and it's a simple command to access it and pull what we need from it, response is pretty quick versus accessing a web server. So it's a little more efficient method for us. And there's also no license costs associated with reading the UCDB file. So what we found in our experience is both these tools provide little feedback when run in batch mode. It's by design, as traditionally large regressions are run nightly and little user interactions required. That's fine. So we implemented our own reporting methods. Since it's either that or we get some default reporting, which is very vague. You get a lot of information about tasks being executed, but you don't necessarily know what all those tasks are, and it can be a little noisy. So we basically took advantage of the user-defined hooks inside of VRM to overload these actions started and completed callbacks, so to speak, and are generating our own messaging, as you can see an example here on the screen. A little more straightforward, just tells you which test is in its current status. So is it pending? It's launched? It's finished? Did it pass? Did it fail? If it fails, we would find and give you the log file. This is a fairly high requirement for us in our environment, because what we want is across the company, we want everybody, when they're looking at a VMS log, they understand what they're seeing. So we don't want one to have excuse me, too much variation in this, and two, we want to, in an attempt to make this a little more vendor agnostic, we don't want to get custom reporting features or information from depending on the tool that we're running. So output control. So what does this even mean? Our experience is users want to be able to move around their tests results folders in a terminal. So you want to go there, you want to find things using Linux commands, whatever it may be. The run managers both force a somewhat non-intuitive naming convention on the output directory names. As you can see here, we get names that are very generic with like, just incrementing integers with no linking back to the actual test name. Excuse me. Not as much of an issue if you're using the GUI. As in the GUI, this is probably performing this mapping for you, and you can go and select your tests and not really care that under the hood it's in a folder called Group 1, Subgroup 1, Run X, Y, Z. However, there's a lot of times when you do want to be on disk and you want to be using Linux commands to find and grep or whatever it may be, and actually having meaningful directory names is pretty powerful. So the reason this is a big issue for us is in our implementation of VMS, we have the ability for a user to define what we call the test tree. This is a hierarchical directory structure that describes the configurations for all the tests in the regression. So you can have branches in the test tree represent different groupings of tests. Nodes in the test tree represent one or more tests. It's very analogous to our VSIF structure or RMDB structure. You can have groups within groups within groups. So one thing that we wanted to ensure that we do is if a user is looking at their input test tree and it logically makes sense, well, when they run the regression, if they go to the output folder, that should somewhat match and still make sense. So to make this, just makes it much easier to find and resolve issues. Creating this exact output directory structure natively through VRM was not inherently possible. So for the test results folder name, so VRM does support a mechanism to name that folder. When we originally implemented VMS, it did not exist. While helpful, we still need to override the full output to exactly produce the output tree we desire. So some of these intermediate levels we are missing. In the case of vManager, the test results folder are simply named run_x, where x is an incrementing integer. There's no mechanism to change this. So what we ended up doing is we have our scripts that are launching our compilations and simulations. Those are actually wrapper scripts, and what they do is they create this shadow structure that matches. It gives us the output we want. Then what they do, they actually CD into that folder and run the simulations and the jobs there. vManager is still maintaining its, and VRM are still maintaining some of their custom logging and output files in their own structure, but this output tree that we generate is really what the user interacts with. One final point is on a major difference between the two run managers is the centralized server concept. So VRM runs as a standalone process per regression, whereas vManager is set up as a server, servicing multiple projects and users concurrently. There are obviously collaborative benefits to this, is anybody working on that project can log in and see everybody's regressions and status, and tracking can be visualized all there. However, there's a cost to this setup in both hardware, custom servers at each site, and maintenance via an admin needing there to continually set up and maintain the server. And also there's license costs as well. A better approach in our minds would be to run the regressions as standalone processes and then still provide a central server where results could be logged as needed. This also has the benefit of not every regression run is logged into the server, but only the ones that you care about. So if you have certain ones throughout the day, that's fine, or throughout a week or a month, but every single debug run itself doesn't clog up the server. So it does also make it more difficult to extract regression data from the session, as it's stored inside a proprietary database. We have to access it using the vAPI or the GUI, again, incurring license costs. All the data stored in VRM is inside of the UCDB files, which again we can access on disk without license issues. To wrap up, I'd like to point out again how we at Infineon have been successful in making extensive use of both of these tools. So we've had good success. VMS was the main digital functional verification entry point for almost all of digital verification users at Cypress Semiconductor before the acquisition at Infineon. We're now actively rolling this tool out to an even larger user base within Infineon. This uniform approach promotes efficiency and reuse, making these tools very powerful. Due to the large-scale adoption of these tools, it's important that we critically evaluate any tools that we're using as a part of it. During our evaluation of these run managers and implementation of them within VMS over the years, we've had excellent cooperation with both Siemens EDA and Cadence Design Systems. Their help and expertise has been greatly appreciated. Thanks again, everyone, for watching the presentation. Be sure to download and read the corresponding paper after the conference. Thanks again. Bye.